This is actually 3 credit subject. Okay, I put 2 credit here. This is 3 credit subject. Is the course outline. In the course content, you have some numerical. That means you will learn some techniques regarding numerical method. In fact, today you will learn about the how can we use numerical method for root finding, and next week you will learn interpolation techniques as well. Okay. In this course, in the end, you need MATLAB software. How can you manage that? Have you already downloaded MATLAB, or have you used that before this session?
නෑ සර්.
පාවිච්චි කරලා නැද්ද?
නෑ සර්.
ඔයාලා ෆස්ට් ඉයර්වත් ප්‍රෝග්‍රෑමින් ටෙක් සබ්ජෙක්ට් එකක් තියෙනවනේ, ඒකට කරෙත් නෑනේ.
ඒකට කරෙත් නෑ සර්.
Okay. How can you solve your device problem? Because in the, at least you should have a computer, because we have to start the MATLAB session as it. Try to find something, okay?
හරි සර්. දිගටම ඕනේ සර් ඒතකොට ඩිවයිස් එක.
මෙහෙමයි මම සබ්ජෙක්ට් එක නම් කරන්න ඕන ටිකට මම යූස් කරන්නම්. මොකද තියෙන කට්ටියට හරි යූස් කරාගෙන එකම දේ ඉතින් නැති කට්ටිය ඉන්නවා නම් ඒකේ MATLAB වලින් assignment එකක් නොදෙන්න එක තමයි. අතෝ සබ්ජෙක්ට් එක නොකර එකට නොකර ඉන්නේ ඔයාලට පාඩුවක් වෙනවා ඉස්සරහට. මොකද ඔයාලට ඉගෙන ගන්න විදිහක් නැතුව යනවනේ නැත්තම් MATLAB. You have 45 lecture hours. There are no practical. Okay. Today I am doing a numerical method for the root finding. Next week I will do interpolation techniques, and third week you have a tutorial class. Okay. In these 2 lecture series, I am not going to do much example. In third week, let's do some example. Okay. Only I just do 1 or 2 example for the lecture series, and in the tutorial class we'll do some more. In fourth week you have a quiz. Okay. In the 7th week actually I will start the introduction session. Then you can understand how can we use MATLAB. Okay. You have 3 quizzes and 1 mid exam. Your last quiz may be your end exam. Okay. If this pandemic situation is continued, then your last quiz will be your end exam. Clear, no?
Yes sir.
Yes, sir.
Yeah, okay. Give me 1 minute, okay? First, see what is the linear and nonlinear equations. Linear equation is the equation that have maximum degree of term is 1. Okay. That means in the linear equations, there are no higher degree. If you take y equal mx plus c, then it is a linear one because there is no higher degree in that equation. When the linear equation value plotting on the graph, you have a straight line. The general form of the linear equation is ax plus by equals c. You can convert that equal to y equal mx plus c. Okay, I think I have learned those things. This is some example for linear equation. Is the third equation this one is the linear one or non-linear one? This one, here you can see higher degree. එක linear and non-linear. Can you hear me now? Can you hear me?
Yes, sir.
Yes, no? So is that equation is a linear one or something else? Since there is a x squared, that means okay, one say non-linear. So others, linear, no? Okay. Reason is what is the x in that equation? When we solve that, you can get
4, sir.
4 for the x.
2,
2,
sir.
sir.
2.
Also minus 2, no? That is just 2 points. That is also linear one, okay? Is the example for the two variable equations. You have no y equal mx plus a equations, no? That's also linear because when you plot that equation on the graph, you can get the linear line, straight line, no? Let's see about the nonlinear. In the nonlinear equations, the not the maximum, actually the minimum degree of is the 2, and there can be a more higher degree in that equation. Okay, this is, I will change that. This should be a minimum. Okay, clear now? When I upload the lecture notes, I will correct that. Okay. This is the example for the nonlinear equations. When the nonlinear equation values are plotted on the graphs, you have a curve. The general form of the nonlinear equation is ax squared plus by squared equals c. Okay, this is like a circle. This is clear, no? This is just for your information. Okay. Is the difference between linear and nonlinear equation? In the linear equation, you can read it, no? A linear equation can be defined as the equation having the maximum only one digit. In the nonlinear equation, a nonlinear equation can be defined as the equation having a minimum degree of 2 or more than 2. A linear equation forms a straight line on the graph. In the nonlinear, it is a curve. Okay. The general form of the linear equation is y equal mx plus c, but in the nonlinear, it is like x squared plus by squared equals c. That is x squared can be changed. Okay, that is can be x cubic or some higher degree. These are some example for the linear and nonlinear equations. Today we are going to do a root finding problem using a numerical method. The root finding, what we do doing is, let's say we have a function called fx, and if the alpha is the root, then if alpha is 0, isn't it? Is that clear? Is that clear? Let's say this is fx. If fx, when fx is 0, then you can find the root. Okay. Then the equation is x squared minus x minus 1 equal 0. Can find the root of this equation and let me know. If you have found, just message them in chat box. You can put the answer. You can use this equation to find new root. Yeah, b equal 1 minus 1, no? C equal minus 1. A equal 1. You can find the root now. Anyone get that answer? Is there anyone who put this value? Okay, good. I will give another problem. This time I will give you simple one. Okay. Mm, is fx. Find if fx is 0, find the roots. Just find the roots of this equation. Yeah, you can write equal 0. You can rearrange this one like x minus 1, x minus 2. Okay, then you can find root as x equal 1, x equal 2. Okay, if I substitute x equal 1 into fx, just find the answer. What happened to fx? Then answer is, and even check f2 also. Your root is x equal 1 and x equal 2, no? So if you substitute that x equal 1 with your function, that means fx, then you substitute the x equal 1 into your equations, just find the answer. Here you just substitute x1, then get the answer for the f1, and next x equal, substitute x equal 2, then get the answer. Yeah, for the both you get you get 0, no? That is what he has said. Okay, if alpha is the root, then if alpha is 0. Okay, is clear now? Someone got -4, it cannot be happen. Okay. I think this is simple things. Okay, I just check your knowledge, but in the upcoming sessions you have some calculations. Okay, so just practice to solve simple equation first. Things most of the students didn't have get the correct answer, isn't it? This is clear now? First, I will erase these things as you can see the things right on the slide. Okay. The number alpha is called as a root of fx equals 0. Okay. The function of fx may be algebraic one or trigonometric function. Okay, trigonometric means some sine curve or cos curve or whatever. Okay. The well-known example for the algebraic function are polynomials. A polynomial of a degree n is written as with this format. Okay, Pnx equal a naught x, a naught plus a1x plus a2x up to an xn. Okay. The number ai is that means ai change I equal 0 to n. These are the coefficient of this polynomial. If a not equal 1, then we call this polynomial as a monic polynomial. Now let's do the bisection method. That is one numerical method to find the root. This is very simple method. Uh, suppose fx equals 0 is then known to have a real root x equal alpha in the interval of ab. Then then the bisect the interval a comma b, that means in that interval, and let get c equal a plus b divided by 2. That means we get the median value between a and b. Then the middle point of a and b is the c, and if the c is root, then then c is the root, then our fx is 0, no? Otherwise, we have to continue this. That means the root may be in between a and c or c and b. Let's check. Let's see this in the graphical example. Okay, I think you didn't get that. Is that clear? Or I will explain it with the graphical example. I mean, with the graph.
Example like පැහැදිලි කරන්න.
Let's say we have a function. This is the function fx. Okay, this unknown function. This is a, this is b. Okay, in that between a and b, you can find if x equal 0 in that point, no? So in that point you have a root. Okay, in the bisection method, what we do is we get the some point called c. We get it as a plus b divided by 2. Okay, then let's say C is here. Then first, what's the value of FA? It is greater than 0 or less than 0. FA is this is your fx, okay. If we substitute x as x equal a, then you can get FA is that less than 0 or greater than 0. This is your fx, this is x, okay. I need the answer for that. Is that greater than or less than? I need the answer for that. Someone said that it is greater than 0. Anyone have another solution, another answer? Is less than 0 or equal 0? What is the answer? And is there anyone who tell this is equal, or someone said this is equal, or is there anyone who told this, who tell this is less than 0? Anyone say that? Actually, answer is sorry. This is, you told this is greater than, but actually it is less than. I am telling this less than. In the f at the x equal a, then your function is here. This is minus, no? Minus value. This is 0, then here plus value, this is minus value. Okay, you can simply get that value. It is less than 0, no? For the FB, it is. Is this difficult to understand? This is greater than 0. Yeah. This is greater than 0, no? So මේක තේරුණාද නැද්ද? මේක තේරුණාද නැද්ද? ඔයාලට ඇහෙනව නේද? Okay. I didn't hear. මොකද කිව්වා? Yeah. Is there anyone who cannot understand Sinhala? First, I will explain in Sinhala. If there is someone who cannot understand Sinhala, then I will explain it in English again. Okay. මේක පුතා කරේ අපි දැන් මේක තමයි fx කියන ෆන්ක්ෂන් එක. හරිද? එතකොට මේ ෆන්ක්ෂන් එකේ a කියන්නේ මේ පොයින්ට් එකනේ. එතකොට x සමාන a කියන වැල්යු එකදී x සමාන a කියන අවස්ථාවේදී මේකේ මේ x වල වැල්යු එක එන්නේ මෙතනට. එතකොට මේක මයිනස් වැල්යු එකක් නේ. මෙතන තමයි a කියන වැල්යු එක තියෙන්නේ. අපි මේක ගත්තොත් එහෙම මෙන්න මෙතන තමයි fb තියෙන්නේ. එතකොට ඒක පොසිටිව් වැල්යු එකක්. මේක නෙගටිව් වැල්යු එකක්. ක්ලියර් නේද? ඒක තේරුණාද?
ඔව් සර්.
හරිනේ? එතකොට මේ is there anyone who cannot who didn't understand this? If yes, tell me, okay? If there is a root, you can see some combinations here. If a into fb if a into fb is change the sign, okay, then this is -0, no? That means this is this one is -1, this is +1, okay? If we can change this both one, sometimes this can be a plus, this can be a minus, okay? If there are sign changes, then we can say that with the mean value theorem, we can say that the root lies on lies between a and b. You can see here the root of the fx is in a and b, no? මේ අපි ගන්න සිලෙක්ට් කරන මේ values දෙක අතර sign change එකක් සිද්ධ වෙනවා නම් මේ දෙන්න අතර ඒ කියන්නේ sign change එකක් වෙන්න නම් මෙයා මේ x කියන axis එක කපාගෙන කියන්නේ fx0 කියන axis එක කපාගෙන යන්න ඕනනේ. ඒකයි මෙතනින් කියන්නේ. ක්ලියර් නේද ඒක? ක්ලියර් නේද පුතා?
Yes sir.
ඔව් සර්.
හරිනේ? I will erase those things. Sorry. I will rewrite, okay? Sorry for the disturbance. Okay. මොනවා හරි ඇහෙනව නේද background sound එක? පුතා මොකක් හරි sound එකක් ඇහෙනව නේද background sound එක? කට්ටිය කතා කරනවා. Sorry for that. Okay.
Loud and
හරි okay. So this is your function. This is A. This is B. This is fx. This is x. Then we get C value, that is A plus B divided by 2. That means midpoint of this A and B. Let's assume here is C. Okay, then tell me what is the value of FA, FC, FB. Is that this one greater than 0 or less than 0? This one greater than 0 or less than 0? First one. Here. This is already negative. This one also.
Positive, sir.
Yeah. This is positive. So the value is less than 0. Here, both are positive, no? This is greater than 0. Now you can see that now the root is in between A and C. Now root is between A and C. It is clear, no? Next, what we are going to do is, next I am get another value, that's A plus C divided by 2. Okay. Let's say here D is here. Then tell me FD FC. Is that less than or greater than? What's that value? It is again less than 0, no? That means your root lies on between B and C. Okay, next, let's say next value is E. Then again we get D plus C divided by 2. Then we get D E is here. Then you can find again F D FD into, you have two branches, no? This branch and this branch. FD into FE and FE into FC, no? These are the two branches for the each iteration. This is C. This is C. Then which one is less than 0? D, you know, this one. This is greater than 0. That means in between E and C there is no root. In here no root. Between these two there is a root. It is clear, no? Likewise, you iterate this point until your whatever you get the C point, that means C1, 2, 3, whatever that last point. Okay, in our case I get E. This is C2, this is C2, this is C3. Next you can get C4. Likewise, you can iterate this, and finally you come to this point. Okay, then you have a root. Okay, this is what in the bisection method what we are doing. Okay, we narrow down the region up to the root point. It is clear, no? Isn't it? පුතා මේක පැහැදිලි නේද? Is this clear or no? Okay, so again I will erase. Now in the bisection method, basically what we are going to do, this kind of things. Okay, this kind of iteration actually. So okay, so yeah. Okay, that is what I have mentioned here. Do you need to repeat these written things, or you are clear with that? If you don't want, I can just pass the slide. Is clear now? Okay, so I will not going to repeat the things written here. This is the mean value theorem what I told you. For the whole iteration, you have to check this. Okay. This is the algorithm. First, input is our fx given function, and you will find two numbers such that for the f naught into f a naught into fb naught less than 0, then you can find the region for the roots. Then you do the iterations until you get the satisfying answer. Okay, first a naught b naught, then it will change. Okay, compute c naught as a naught plus b naught divided by 2, then c1 is the a1 b1 divided by 2. Okay. If ck is in the desired root, then we stop the algorithm. If ck is not in the desired root, we do the iteration process again and again. Okay. Then until find the desired root, we do the iterations. I think this is clear, no? In this algorithm method, you need to know these things, because when you write the program in the MATLAB, you do that according to these steps. Okay. It is clear, no? Do I need to repeat it, or just go for the next slide? What do you want? Shall I want to repeat it too? Okay. If not, sorry. Okay. Now let's do some example. Okay, you can do this. This is your function. Using bisection method, you have to find the solution. Okay, as a first point, we equal our fx into 0. Okay, then we substitute x equal 0, x equal 1, and x equal 2. You can do if you want further. Now you can see that in generally for this is cubic equation, so you have 3 roots, no? In this case we find 1 root. Okay, then you can get the idea for that. Likewise, when you substitute x, you can find some regions fx is changing, that's plus minus. Okay, then you know that in between those 2 values there is a root. Clear, no? In this case we are going to find 1 root. Okay. Do this process. Just substitute 0 for the fx and find the value. It should be a -1. If you substitute 1, again you get -1. For the 2 you get 5. Just find the value. If 0 is -1, f1 you get again -1. f2 you get to the power 3 -1, sorry, -2 -1. Then you get 8 minus 2 minus 1, then 5. Okay, it is clear now? It is clear now?
Yes, sir.
Okay. Next, what we want to do? Next, you have to find C value. C is between. You no need to now get the 0 value, because you know the root is lie on the root is Python one and between in 1 and 2, no? So your intermediate point is 1 plus 2 divided by 2, then is 1.5. Okay. Then you check the first iterations. Root lies between 1 and 2. Then your x naught is 1.5. Then check what's the value for the fx naught. Okay, you can substitute 1.5 into your fx. For the second iteration, your f1 is -1. This is -1. And let's say this is your function. This is 1. This is 2. Now your value is 1.5. It is the 1.5 value is greater than 0, no? So that means it is this graph. This is fx. This is 1. Let's say this is 2, then 1.5 is here. Because in the 1.5 you have some f naught value, it is 0.875. Okay, so now you can see that f1 into f1.5 less than 0, because this is negative, this is positive. Now you can understand that our root is lie on 1 and 1.5. Okay, likewise we do the iterations. Again you find the value between 1 plus 1.5, then check that value, then check that fx1 value. Okay, it is clear, no? If you didn't understand, tell me. We do the same things in that graphical example. Okay, it is clear, no? තේරුණාද නැද්ද? Someone can tell me Is that clear or not? Did you understand the second iteration? Okay, now you can continue. This second iteration, in do some few iterations up to fifth, and let's check what are the answers. Okay, I will give around 5 minutes is enough. Or 5 or 6 minutes I will give. Do until up to six iteration. I will give 6 minutes. Okay. Or otherwise, I will give 10 minutes. Do the iteration up to 10th. Then I think you can get the final answer. Not in the 10th. Okay. Do some iterations. You have to do same things. Okay. Just check where is the root, the revision for the roots, and do the same iterations. Okay. After 10 minutes, I will check the answers. You can do, okay. Did you finish? Still you are doing the iteration now? Have you finished that? If you have finished, we can check the answers.
Still doing, sir.
Sorry.
Still doing, sir.
Okay. Okay, let's see the answers. Okay. New third iteration. have you found that this one? Then in the third iteration, your root lie between 1.25 and 1.5, isn't it? If yes, in the chat box, put yes, okay? Then x2 is the median value of these two values. Then you get 1.375. We substitute that answer into this x2 into the function. Then you get 0.22461, that is greater than 0. Then you know that then you can see that if 1.25 is less than 0 and if 1.375 greater than 0, that means in the fourth iteration your root lie between 1.25 and 1.375. Have you got these answers? Anyone? Can you put some message in the chat box if you have found these values? Okay, good. In the fourth iterations, root lies between 1.25 and 1.375. Then again we find x3, that is 1.312 and 125. Then that's value less than in the when we substitute that into fx, then you get the minus 0.5151. Okay, now our next points are 1.3125 and 1.375, because these two in between these two values the sign value is changed. In the fifth iterations, then you will get you will get x4 value as 1.34375. Then we substitute that into fx, then you get fx4 as 0.08261. Then you can understand that our root lie between 1.3125 and 1.34375. Yeah, now we are narrowed down in the region. No? We can understand that. Okay. In the sixth iteration, you get x5 as the 1.32812L. That means it is greater than 0. When it is substituted to the fx, you get fx5 greater than 0. Again, our root lie between 1.3125 and the new value what you have found, that is 1.32812. Okay. And here you can see another things. your fx value is reaching to 0, no? That is what we need in the root. Your fx should be 0. Okay, you are reaching now into some root. It is clear now? If you carefully see the answers for the fx1, s2, s3, s4, s5, then you can see that value is reaching to 0. That means you are going to some root, isn't it? පුතා මේක පැහැදිලිද?
Yes, sir.
Okay, good. In the 7th iteration, you get x6, that is 1.32031, and when you substitute that value, you get minus value. That means your root lie between 1.32031 and 1.32812. That means in between this and this, because this is minus 1, this is positive 1. Okay. In the 8th iteration, you get x7 as the 1.32422. And when you substitute that, you get this value. That is negative. That means again your value is between this and this. Okay. Again, you get the x8 value. You can see this is positive. So your value between, for the next iteration, your value between these two. Okay. Here, again, it is positive. That means value for the next iteration, your value between these two. Now this is negative value. So your root between these two. And we are not going to iterate more because you can see the your fx value. It is almost 0. Okay, it is 0.0005. We can assume that this is 0, and your root is this one. It is clear now? Anyone got this answer? Is that clear? Anyone get this answer? Yeah, okay, good. And do the same example 2-3 times, then you will get that familiar with that bisection method. We'll do some example on 3rd weeks. More example. Okay, this is a very simple example. We'll do some complex one as well. Okay. Next iteration method is fixed point iteration. It is bit complex than the bisection method. Also, some story here. You can read these things. Here we will get a function. We have a fx function, but we will select some gx with in the fx. That means we get some part of the fx as gx, and we written it as a x equal fx function. We rewrite as x equal something. The something is the gx. Okay. If we substitute the root for this x equal gx, then you will get 0. Before moving to other things, it is better to do some small example with this fixed point iteration. Then you can easily understand. Let's do some in that way. Let's assume you have a fixed it's like start minus x minus 1. I have given this to you to find the roots, then you know the roots here. It is the answer minus 0.618, and the thing is 1.618. I think you have remember, no? I have given this in the beginning. So in the fixed point iteration, what we are doing is we find the function equal to gx. Okay. In our case, and what we are doing is actually we get the next iteration for the x by previous one. In this case, let's get this is our fx. When fx is 0, then we have root. So here we can get square minus x equal 1, and this is x into x minus 1 equal 1, then x 1 over x minus 1. Okay. Then we select this part as gx. Okay, that's what we do in the fixed point iteration. In the fx, we get some gx. Okay, that satisfies x equal gx. Is that clear? Yes or no? If not, tell me.
No, sir.
Okay, again I'll repeat it. Okay. This is your fx function. You want to find the root. In the beginning, we found this root. That is why I wrote here. In the fixed point iteration, what we're doing is we find the gx function to satisfy it equal to x. Okay, gx can be anyone. That's what I did here. When fx equal 0, you have a root. When this is equal to 0, then you have a root. So to find the root, I will equal this to 0, and then x squared minus x equal 1, because I get this one into other side, then it is plus 1. Then here x is common, then I will get out the x. Then x into x minus 1 equal 1, then x equal 1 over x minus 1. Here I use this 1 over x minus 1 as the gx. Okay, you can get anyone. Only you have to satisfy some conditions. Let's see them later. For the gx, it should be satisfy some conditions. Now it is clear?
Yes, sir, clear.
Okay. Let's do some iterations. Okay, then you can see some answers. I think it is easiest way to take this. This is x. Okay, this is dx. First, I can be changed. Okay, I can be 1 to anyone, 1 or 0, whatever you can use. This is some iterations. Okay. Here we will start with x equal 0. When we put x equal 0, our gx is what? This is our gx, no? This part of gx, then gx is, when x equal 0, what is the gx?
0.
When x equal, here x equal 0, then answer is, this answer is?
Minus 1, sir.
Minus 1, no? Yeah, then we substitute this minus 1 as the x. Okay, now here you can see I write here is I plus 1 equal gxi. Okay, that means according to our this example, this is 1 over xi minus 1. Okay, our next iterate for the next iteration, we substitute this minus 1 here. Then our answer is
0.1, 0.5.
0.5, no? Next we put 0.5 here. Then our answer is 0.667. Likewise, we can do in the 9th iteration. You can get the answer as this is 0.618. Okay, that is also 0.618. Both are same. That means we are in the root. That is your first. This is your first root. Okay. When you do some iterations, you can go for the root. If both are same or very close, then that is the root. Clear? Is clear now? This is 9th iteration. Okay. You have 4, 5, 6. Then you can just substitute and just check. If we select gx like in this format, that means 1 over x minus 1, you can find one root here. Let's check another method. Uh, Here let's get squared minus x minus 1 equals 0. Then we will find another gx. Here x squared equal x plus 1, no? Then we can divide by x, then we can write this is okay. When we divide by x, now this is 1 and this is 1 over x. It is clear, no? Isn't it?
Yes, sir.
Clear, no? Okay. Then this is our ex. We will do same things again. This is 1, 2, 3, something. Here what we can put? Can we put 0 here? I need the answer for that. It's a general thing. What happens if I put 0 here? Yeah, good. Yeah. If I put 0, the answer go to infinity because in here 1 over 0 means just going to infinity. So we would put 1 here, 1 here. Then dx is 2. Now x is 2, then dx is 1.5. Now x is 1.5, then dx is 1.667. Likewise, around 10th iterations, you can get x equal 1618, dx also 1.1618. Then you will get your second root. Okay. And other things, just notice that here you can see the value is going to smallest one. Here also we start from 2 and it is for the each iteration the value is that means it's not going to high value, okay, more than 2 or something. And let's get another way for the dx. This is clear, no? Yes. Okay. Next time, let's get okay, here now x minus 1, 0. You can get x equal x squared minus 1. Then this is Ex. Now let's see what happened. X, Ex. 1, 2, 3. Okay. Here put 1. Then if you put 0, then minus 1. Minus 1. If you put 1, then what is the answer? Hmm? 0. If we put 0, then the answer is again minus 1. If we put minus 1, then again you get 0. So this is not going to converge. Okay. Here we are going to converge some point, but in this case, this is not going to converge. Okay. So we cannot get all the GX. That means when we select the GX, there should be some the GX should have some properties. Okay, otherwise you will go to some infinite or some unwanted values. This is clear, no? So if it is clear, I will erase this. Now let's see some graph. Okay. This is y equal x, and let's get another curve. This is our this is y equal Ex. In that point, what happened? In this point, y equal x and dx. No, this is what we need. Okay. Then this is the point. Let's say this is our root. This is our root. What we did with our last example. This is, let's say, x naught. Then we are going to find some dx value. Okay. Then this is, let's say, dx naught. Next, what we do? According to that value, we find some x value. This is our next iteration. Okay, this is x1. According to x1, we are going to find some this is dx naught. This is gx. This value is gx1 now. Okay. Likewise, you can see here we are moving to this root point, no? here. We are moving to this point. For the next iteration, I will in here we get the x and okay, this is our gx2. Okay, then this is our x2. Then you are close to this point. Okay, then this is converging to actually this is now this is convergent. Okay, if we get some another here, this is our y equal x, and we will get another dx. This is y equal dx. In this point, we have our x equal dx. This point, this is our root. In here, this is our first x naught. Then for the first x naught, we can find x value. This is x1. Then this is the dx1. Okay. Then we can find dx dx1 here. Then you are going to find your next x value, x2. Then you get dx2 here. Now you can see that you want to go here, but you divergent from that value. Okay, this is divergent. It is clear. Depend on the gx what you have select. The gx can be convergent or divergent. Is that clear? Clear or no? Not
Clear.
okay. Okay. Let's see some convergent analysis is in the mathematical form. X equal gx, and let's say R is the root, then gr equal to our root. Okay, R is the root. What is the error then? Our EI for the iteration is equal to xi what we going to for the each iteration we find xi, then our root is r, then our array is the xi, that means whatever things we find for the iteration minus r. Okay. Value, this is yes value, this is error for the each iteration. In last slide I told you we will get the next iteration using this function. So now our EI equal is the guess value, then I plus 1 minus real root. With the mean value theorem, you can get if dash, let's say this way. You have fx function, and we assume that we have f dash x as cell in between a and b, and that value is c. Okay, then f dash c equal fa minus f b divided by a minus b, a minus b. Okay. This very simple one we get in here. What we have found is the tangent. Okay. Fb is the as example, this here. Then let's see. We have some function here. This is C. We want to find tangent here. Sorry, tangent value. This is A. This is B. Then this is this is B. This is C. This is FA. This is FB. Then if dash is the tangent, then it is FA minus FB divided by A minus B. This is the tangent. Okay. This is, I think, clear. Linear derivative. Okay. Then we can rewrite this equation. FA into FA minus FB equal F dash C to A minus B. Okay. Then we substitute this one into this equation. Okay. Then here actually you have not EI. Okay, this is EI plus 1. No? According to this decision. According to this is EI plus 1. Okay. Then we can write E plus 1 equal G dash G dash C into X I minus root according to this fashion. Okay. Actually, here you can rewrite this equation equal to G xi minus dr. Okay, because r equal gr here, and here xi plus 1 equal gxi. That is why I write this way. So then you can get this equation, no? And this is our EI. Then we can rewrite this I plus 1 equal E dash C Wait, Buddha. Some unwanted sound. Okay, give me 1 minute. Okay. Then our to minimize the error, what should be happen? Our G dash C is less than 1. Then this is going to convergent. If G dash means the derivative of the Gx, okay? In here, in the C, derivation of the C point. If it is greater than 1, then this is divergent. Okay. This is the mathematical analysis for the convergence analysis. So I think it is clear now. Is it clear? Just watch the video 2-3 times, okay? Then you can understand. So I will erase this and just move to the next session, okay? So this is the general things for the fixed point iteration. Just read the things. Okay. This is the mean value theorem that we use to prove the convergence analysis. Is the theorem. Here you have to check the GX dash and check whether it is in between A and B, it is less than 1. Okay. Then your GX is proper one. Otherwise, your answer not going to the root and it is divergent. Okay, let's do some example. I'm not going to repeat this, okay? You can read it and understand it with the symbol. This is a mathematical form. That's what I have explained, okay, with the example. This is the example, previous example for the bisection method. Just find the answers. If you can get the same answers, yeah, okay. Here again, you can get the, it is easy when we select the, where is the root, by just substituting x values. You can find again your root lie between 1 and 2. Then you can do the iterations. First, you have to find the gx function. Your gx is here, cubic root x plus 1. Okay, this is bit complex than bisection method. Okay, so just do the example 2-3 times. Actually, I'm not. That means I have proved something. No, in the exam, I'm not going to ask that. Okay, that's for the thing that is for general knowledge. And only thing is you should have ability to find some roots with the fixed point iteration. Okay. Up to now it is clear. Yes or no? Isn't it clear? I can repeat it. We'll do this example. If you can do this, you are okay. This is like a previous example. When I start the fixed point iteration, I did some example. No? This is similar one. The thing is, this is a bit complex than the previous example. Shall we do? I'll go for the first iteration. This is our gx, okay? Gx is the cubic root x plus 1. Then you have to find the gx naught. Here we get our x naught as 1.5, okay? You can get any arbitrary point here. But thing is, if we go in this way, you can easily go to the root. Okay. Here only thing is your gx is cubic root x plus 1. You have to just substitute the values here. For the x1, gx naught is g 1.5. You substitute 1.5 in cubic root x plus 1. You can get x value. Then you substitute x1 in gx. පුතා මේක තේරෙනවද නැද්ද? You can straightforwardly do. Only thing is you have to find some gx. Okay, depend on the gx, you will go to the root. When you find gx, you have to check whether that gx dash is convergent. Is this clear? We'll do more example in third week. Okay, today just do that example. Okay, these are the answers. In the sixth iteration, you can get answer. Other thing is, in your bisection method, you have to go for the 11th iteration, I think. In here, it is less than 11. So this is bit past than the bisection method. In the 8th iteration, you can get the answer. Same answers for the GX7 and X7 and X8. The X7 and X8. Actually, in the 6th one, you can get the answer. No? After that, same answer repeated. Isn't it? You can do it. And if we select your gx in another way, let's say in the power of 3 minus 1, then your gx not this one, x2 is bit high value. You can see your value is go infinity. That means your g dash 6 is greater than 1. How to find the g dash 6? Huh? In this case, how to find the g dash? What is the g dash 6? In this case, what is the g dash? In the calculus, I think you learn this, okay? When you are in the first year, no? I think in the last semester, you have done that subject. What is the g dash 6? It is 3 squared, no? In between 1 and 2, if x in 1 and 2, when you substitute any value in the 1 and 2, your g dash 6 is greater than, even if x is 1, then you have 3. So in other cases, your g dash 6 is greater than 1. That is why this value is going to divergent. In this case, in this one, when it is less than 1. What's the g dash x here? here you have x plus 1 over 3, no? So you have to differentiate that. That's all. What is your answer? We'll get 3.5. Then you will get plus 1, this one minus 1, this one minus 1, and after that you have to multiply by 1 because derivation of the x is 1. Then you will get 1 over 3. Here you will get minus 2 over 3. Then you will get x plus 1, 2 over 3. For all the values, you will get between 1 and 2, you will get less than 1. Okay, just check. Okay, I am not going to do all the things. Okay. What do you like? Shall I? Actually, I hope to finish this one as well in today's lecture. Now it is around 11:30 now. If you, I think you are fed up with the lecture. So if you want, I can do this today. Otherwise, we can postpone this into next lecture. Newton-Raphson method. What do you like? You can talk in single. Okay. මොකද කරන්නේ? කට්ටිය ඉන්නවද? නැද්ද?
ඉන්නවා සර්.
තේරුණාද fixed point iteration එක?
ඔව් සර්.
තියෙන එක්සැම්පල් එක ආපහු පාරක් කරන්න. මම අර කලින් කරපු එකත් ආයෙ කරන්නද? ඔයාලා සම්පූර්ණයෙන්ම කරන්න ඒ ටික. නිව්ටන් රැප්සන් මෙතඩ් එක දැන් කරන්නද නැත්නම් ඊළඟ සතියට පෝස්ට්පෝන් කරන්නද? ඒක නම් ඉච්චර වෙලා යන එකක් නෙමෙයි මේ මම ඕන ඒක ඊළඟ සතිය කරන්න. කරලා ඊට පස්සේ ඊටු ටික ඉන්ටර්පොලේෂන් ටික කරන්න. දැන් ගොඩක් වෙලා ඉච්චේ කරානේ. ටයර්ඩ් නැතිනේ. What do you think? Okay. So I will stop for today and just do the example what I have did today. Okay, what I have done today. So other thing is there anyone who cannot understand Sinhala? Yeah. Okay. Anyway, in the next week we will do the Newton-Raphson method and interpolation techniques, and I will give some tutorial with some examples. Perhaps next week after the lecture I will send some tutorial. Okay, you can try them in home. And let's do the tutorial on third week. Are you okay with that?
Okay, sir.
Okay, no, because I did very simple.
Okay, sir.
Okay, I did very simple example. There are so complex one. At least let's do some at least one complex problem solving. Let's do some complex. Let's solve some complex equations. At least one. Okay, in the quiz I will not going to ask very complex one, but as in the lecture I think it's better to do some complex one as well. I think the things that I have done today is, I hope it is clear. If not, tell me, okay? Then shall we stop now? If you have any problem, you can ask. Yeah, so then stop. Okay. And bye, okay?
Thank you, sir.
Thank you, sir.
Thank you, sir.
Recording stopped.